Okay. Then we are working on a digital support system in coronary artery disease. That is a disease caused by atheromatoous obstruction of coronary vessels. Coronary artery disease is a result of atherosclerosis process of the coronary artery, consisting in the narrowing of blood vessel and the artery of its walls. Coronary artery calcium score has been used as a diagnostic marker measuring the coronary atherosclerosis progression, and the aim of this work is to show medical results obtained in the automatic estimation of Addison score and calcium volume score. So, the coronary artery disease reporting and data system that is CAD-RADS from 0 to 5, as shown in the image. In the images, is a method used to facilitate the recording and communication of coronary angiography results. The classification using CAD-RADS includes several factors, such as the release of stenosis, patient risk factors, plaque morphology, image quality, and the presence of cardiac bypasses. For the CAD-RADS extraction, it's essential to compute the segmentation of the plaque in order to estimate Addison score and calcium volume score. Addison score is an index that computes the area of calcified coronary plaque in a computer tomography slice of 3 mm, having a density that is greater than 150 units, multiplied by a weighting the density factor based on the maximal CT number of the plaque. Instead, the calcium volume score is obtained by multiplying the number of calcified voxels by the volume for each voxels, considering all voxels with more significant inclination than 150 unskilled units. So this is the two index that we have attention in the work, and are shown in the following slides. The methodology that we used involved a different approach that has been explored. The method selected consists in a U-net convolutional neural network architecture built from residual unit to segment the artery calcification. U-shaped encoder-decoder network architecture is composed of five encoder block, residual units equal to a convolution with a stride of 2 for downsampling, transpose convolution with a stride of 2 for upsampling, and a layer for a patch normalization. We used evaluation metric that are dice score that measures the similarity between segmented images and the ground truth, dice loss that compares the similarity of two binary classification of an image, and accuracy that represents the ratio of correctly segmentation samples. We used a pre-processing pipeline with activation of the storage metadata in an album. We have a file conversion in NFPA format. We had a windowing of the anatomical structure of interest, contrast improvement of anatomical structure on the background, and then we used documentation and crop images to remove artifacts to ensure medical interpretation. After the the preprocessing pipeline, we process in the UNET, and we used 50 located CT scan for feature extraction, and on a total of 30,007 total images, and calcified areas of the arteries occupy a very small portion of the images, as you can show as is shown in the images. That is this one. This portion that is orange is that we have identified with the neural network. So the accuracy become either in the output, and the segmented area identified appears similar to the ground tract, as you can show in the ground tract. The numerical experiment, so the prediction of Agathon score and calcium volume score is more accurate for 4 out of 5 patients, as you can see in the numerical table. The preprocessing technique improves largely the results and the estimation of dice score. The accuracy of the current method stands at around 97%, as you can show, as it is shown, in the numerical table. These are the ED patients. And you can show that you can see that the dice score and dice post-processing with a subsequent post-processing is very close to 1. This is the maximum of the index. Thank you for your attention, and if you have any counter question.
Thank you very much also for taking time. We are late. Is there any question from the audience? Yeah.
Thank you so much for the presentation. I think the results are very nice. Only, I would like to perhaps you can explain me a bit better the post-processing step that you apply to the image, because the increase of the performance was very large. Which kind of processing you apply?
So we have 2 steps of processing that use the neural network, and with the same neural network, in the second passage, we have an area that is very similar to that we can see in the medical image. So the contour of the area identified by the algorithm is very similar to that present in the images that you can see in manual application.
Okay, if I understand, you have 1 minute to make the localization of the calcium.
I have a localization of 90-70% with 2 processing. Instead with 1 processing, I have something that is more or less. Anyway, the calcium score, the 2 index that I have shown, are improved after post-processing, and are that the interest in medical application.
Thank you so much.
You are welcome.
And now the last presentation of this